We present EMDB, the electromagnetic database of global 3D human pose and shape in the wild. EMDB is a novel dataset that contains high-quality 3D SMPL pose and shape parameters for in-the-wild videos. To provide this data, we use up to 12 body-worn wireless electromagnetic sensors and a handheld iPhone to capture human motion. Together with accurate body poses and shapes, we also provide global camera poses and body route trajectories as shown in this sequence. To construct EMDB, we propose a method called Electromagnetic Poser, or EMP. EMP is a multi-stage optimization procedure that works as follows. In a calibration step, we first scan a subject in minimal clothing with an indoor multi-view volumetric capture system to obtain their reference SMPL shape. After the sensors are mounted, we calibrate skin-to-sensor offsets via a short calibration sequence. For a given in-the-wild recording, we then fit SMPL to the electromagnetic measurements in the first stage. This fit is an EM local coordinate system, as all measurements are relative to a source worn on the lower back. Thus, in the second stage, we align the SMPL fit with the world, which we define to be the tracking space of the handheld mobile phone. This stage takes as input the outputs of the first stage, EM measurements, 2D key points, depth, and self-localized camera poses and produces world-aligned SMPL pose and shape estimates. In the third and final stage, we refine the SMPL estimates from the second stage via fitting a neural implicit avatar model to reconstruct detailed human surface geometry and appearance. This allows us to formulate a dense pixel-level objective to boost pose-to-image alignment and smoothness. With this multi-stage design, our final result displays high quality both for 3D pose and pose-to-image alignment. Our evaluations have revealed that EMP achieves 2.3 cm positional and 10.6 degrees angular error compared to ground truth recorded with a multi-view capture studio. We use EMP to produce EMDB, a novel dataset of 3D human pose and shape recorded in the wild. EMDB contains a total of 81 sequences, 105,000 frames, distributed over 5 female and 5 male participants. It contains several sequences with challenging poses and occlusions. EMDB also provides global trajectories, which allows researchers to study the emerging task of global human and camera pose prediction. Here we visually compare to a sequence taken from our most closely related dataset, 3DPW. We observe that 3DPW sometimes struggles with alignment and unrealistic poses. In contrast, a similar sequence taken from EMDB does not show such artifacts. Note that the image-to-pose alignment is a characteristic that is typically not picked up by any metric. We evaluate recent state-of-the-art camera relative pose estimation methods on EMDB and highlight the performance of the top 3 methods here. We see that despite impressive progress in recent years, there is ample space for improvement for future research. All these results were obtained by supplying ground truth bounding boxes to the respective method. Finally, we also evaluate recent work on the task of estimating the global body and camera trajectory. Here we show the result of glamour on a loop closing sequence taken from EMDB. While the reprojected local poses look reasonable, the predicted global trajectory of glamour drifts significantly. With several interesting global trajectories included in EMDB, We believe it will play a major role in advancing future work in this challenging field. Thanks for watching.